Okay, in this following example, it's going to show that the shell method works just as well if we rotate about the x-axis. We simply have to draw a diagram to identify the radius and the height of a shell. In example 3, using shells for rotation about the x-axis, we're going to use cylindrical shells to find the volume of the solid obtained by rotating about the x-axis, the region under the curve, y is equal to the square root of x, from 0 to 1. So here we are going from 0 to 1. There's our graph. Y is equal to the square root of x, and then we're rotating it according to the x-axis. Now if we solve for x, it's going to equal y squared. We have a vertical line at x is equal to 1. And so now this problem was solved using disks back in example 2 in section 6.2. Now to use shells, we relabel the curve y equals square root of x in the figure in that example as x is equal to y squared in figure 9. For rotation about the x-axis, we see that a typical shell has a radius y, circumference 2 pi y, and the height 1 minus y squared. So the volume is the following. Going from 0 to 1, the circumference, which is 2 pi y, times the function 1 minus y squared dy. And therefore, factoring out 2 pi, distributing the y to get y minus y cubed, taking the antiderivative, using a lower limit of 0 and upper limit of 1, would then give us the solution for pi over 2. And as you can see here in this problem, the disk method was simpler.